So again, as you guys recall, that electrons can carry the charge, and in conductors we have free electrons, and they can very easily move about and create a positive or negative charge being moved from one point to another. So the electrons can move more freely in conductors and not the same in insulators. So if I take two conductors and one has, say, plus 20 charges, and I touch them both together, the other one is neutral, they'll both divide all the charges till they both have 20 charges. And we'll talk a little bit more, and I want you to make sure again that you always make sure that whenever anything is positively charged, it's not because protons were added. Protons cannot be added, cannot be removed. Keep that really clear in your mind. It's the electrons that are going to be doing all the moving in our exercises, okay? All right, so how are objects charged? So obviously, again, if an object has a positive charge, it must be short in electrons. These electrons are missing. And an object is negatively charged, that means it has extra electrons. So here's a nucleus, and I take an electron out, and it'll be positively charged. I put an extra electron in, and it'll be negatively charged. Here is a negative atom because the number of electrons is greater than the number of protons. Now, how much charge does an electron carry? That's 1.6 times 10 to the negative 19. So a really, really, really tiny amount of coulombs. C is a measure of units called coulombs, spelled Coulombs. You'll see it again over and over again, and then you'll kind of get sick of Coulomb in a bit. So it's a unit charge. If I say something has a mass of 30 kg, the units I'm using are kg. And the units for charge, I say I'm holding, 0.014 coulombs of charge. And so that's an amount of charge. And so coulomb is a unit. And so this is the smallest possible unit you can have for a charge. It'd be negative 1.6 times 10 to the negative 19 coulombs. Again, for the physics we're doing. The charge of a proton is exactly the same number, and it really had to be, otherwise the universe wouldn't be the way it is, if at all. And the charge of a proton is a positive 1.6 times 10 to the negative 19 coulombs, while for the electron it's negative 1.6 times 10 to the negative 19 coulombs. But really tiny amount, a tiny number, okay? One coulomb is a lot of charge. It's a huge amount of charge, okay? It's You never talk about coulombs as, hey, I got 1 coulomb of charge in my hand here. If anything, it'll be in microcoulombs, so in 10 to the negative 6. And even that's going to give quite a zap if you come close to it. Okay? So, again, this is the tiniest possible charge. So, when I take an electron out, it'll have a positive charge of so much because I have an electron missing, so the proton's going to be stepping in. Or if I add an electron in to an atom, it'll have that much extra negative charge. Okay, back to some basics. Um, you guys know that charges that are the same type, positive and positive, will repel, get away from each other. Unlike charges, positives and negatives will pull towards each other. So protons and electrons are attracted. Protons and protons are repelled. Um, and that's basically all there is to it. It's kind of cool. This is one of the fundamental forces of nature. We've met gravity. This is a second one. I call them spooky forces because, they can act at a distance. So, I just bring this charge near here and this guy will just get